So hi everybody and welcome back to such C++ tutorial series for absolute beginners. This is video 246, and in this video we continue with virtual base classes. You can see this is this page where we stopped, and we have not talked what the keyword virtual means. And now, right, let's dive into this one. So I showed you this one already, where we use the virtual keyword, but what means virtual keyword? For this purpose, I mapped this one here in Paint. You can see this is just a little bit a diagram which says the B here, which you can see here. Let me show you this again. This B here is the struct B. Here we can see it. Then X, Y, and Z. X is here, Y is here, Z is here, and this struct AA is here. All right, the only keyword virtual we have in X and Y, so I have make here a circle which indicates this one is virtual and Y is virtual. So this is a diagram which shows what we have to understand. The problem here is, before we can understand this one here, we have to understand what it means inheriting without virtual. We have talked about this one. So when we inherit normally, which is an extension, but we have not talked about it when we inherit in multiple inheritance, right? I said there is a new feature when you see this AA has a multiple inheritance here, which is the only difference is we make a comma separated and add all what we inherit. Again, they are using here X, Y, and Z, but you can of course use here also this access specifier. You can make here even virtual and all this kind of stuff too. So for that, let's go here to this here and understand what means inheriting first of all without virtual. So just normal inheritance but multiple. So for this purpose, I make here again a base class, but I call it this time A. This is the base class from which we will inherit. And then I make again two classes which inherit from A, B, and C, but this time without the keyword virtual. So they are not virtual. You can see the keyword virtual is here circled. And here is even an example without circle. We will talk about this later. And then I make one more class which inherits multiple. You can see this BC inherit only one time, normal inheritance, and this D here will inherit multiple times. You can see I can inherit here, here. So we have to understand now what happens here. So without the keyword virtual. So it's very easy actually. So we start from the bottom. So let's say this one is the last class, and let's see what happens with B and A. So when you go up to B, it says, okay, I am D, the last one, I extend B. We learned it, right? Inheritance means just extension. I take all what is in there, not all. We learned this also. It depends on the access specifier. You can take all, or let's say almost all, because the private you still can't take actually, but which is made for access you can take all. That's the real meaning. For example, you want that B take all, then you set it in the access specifier, for example public, and you inherit this one also public, and we know public means you take it like it is, right? So you can take all, but careful, private you can't take. But that's we will make them more examples. But important right now is what happens here, because B inherits from A. It's also a normal extension, which means B is also here just an extension of A. Again, the same rule like here. You can take all or not take all, depends on the access specifier, which we learned. But important is now this B make here an arrow here on top A. That's very important. And when I go now to C, now let's go to C, the same thing here. This D can take all, depends on the access specifier, and the C can take all again from A because I inherit all from A. But important is here, you see something. The normal inheritance without the keyword virtual is creating two e's, right? Which means I have different e's. What is the meaning of different e's, right? The meaning is when I create here, I try to manipulate something like in E. We learned, right? Inheritance means the E can have, for example, let's say in E is a variable, it's called int var, and we assign it, let's say, the number 1, right? So this is an E. In E has this int variable 1, and I can access it from here if I have the rights. All this we learned, all this access specifier must allow it to inherit till this point, and I can change it, right? For example, I set it this variable here var. I can write here var 4, right? And this var 4 is changed in A, but interestingly, it is changed only in this A here, not here. What I mean with that is, if you want change it here, you can do this here as well, but you can already see here a problem. How do I know that it is changed here or here in a normal inheritance, right? You can see why, because right now I can say, okay, I change it here, like I show you, but which one is that? And the C++ compiler makes the same thinking like you. He will say, okay, this one will not work because I don't know which one you mean. You want here the change or here? And the solution for this is, oops, let me take here fast this one and put it a little bit down. The solution is, we know it, we have to use this class resolution operator. This is just a double colon here, double, we know it. And we know this class resolution operator means look the place what I specify. And I say, okay, I want that you go to first to B, and what B inherited, and then you can change this one here, what this one created. So when I make B var 4, I will manipulate B's A. The B's A is created here. And when I want manipulate this A from C, then I have right here, oops, C. Go to C, var, and 4. But this one is not so important right now. We will dive into this example a little bit more, how this works, because we have not made examples. I want just show you inheritance, a virtual keyword right now. And the virtual keyword says, okay, without virtual keyword, you are creating two separate A's for this inheritance. Here, let's go here now. Let me make this a little bit bigger here. Let's go here now to this section. You can see we start again with a base B. This is our first class. And here, this time, you can see it's similar to this picture. The only difference is I have here one more. It's possible, of course, I can inherit it how many times I want. The difference is we have here virtual, and here is our normal, like this one. The set is a normal one. So, and here my AA is my D here, and this time I inherit 3 times instead of 2 times. But important is what happens now with this one here. So we make here a similar example like this one. I show you this one. And the difference is now AA starts here. Let's make it so. Then AA goes to X, but this time I have the keyword virtual here, right? In our example. And then it creates a B like normal. It creates a B like normal. You see, that looks similar to this one. I go D, I go B, I create E. But important is now what happens with the second virtual. That was the first. The second one. The second one says, okay, I inherit, but I'm also virtual. And this one says, oh, I'm virtual, and there is already a B. I use this one. that's very important that you understand that this one here, the keyword, is not creating a new one. They are sharing one base. And the difference is with the C here, he will still create a new one. So you can see this one here is not a virtual. So what happens here is the C, this is like our normal one. He said, I'm C. I am not virtual. I have not the keyword virtual. I create my own B. And that is what you have to understand with this virtual keyword. They are sharing. The non-virtual are not sharing. And like I said before, we have to learn how we can access them, address them, like here, because the compiler will say, for example, here in the non-virtual, you have to clarify how you access and what you want access. Here, I have this problem not. For example, in this virtual, if I have here in B, I don't know, a variable, which are shared by them, I can make this without an access specifier, but we watch this later in the code a little bit. Important is that you understand just this little thing what I explained to you here. That's one. They are sharing it, and this one is not sharing it. And now in the code, we will see how this works, because if you understand this, we will understand this. And I think we should go into it, this one in this video as well. Okay, let's go into it, the code. You can see, let's see if I do this one or I use my, I think we use this one, this one here. So let's see. Let's try to understand it here. If this not works, we make an example with my code as well. So here we have this one. You can see the base has only one int n, right? The base has this. Again, this one is virtual. This one is virtual. You can see this is my example. They are creating not a new B. The only one, the last one, the set here is not virtual. He will create its own B. So, and now, and actually this comment here says exactly the same thing, right? When you read this, A has one X, Y, Z. You can see A has one X, Y, Z, like this one here. And then one that is base of Z. So base of Z, where is our Z? Oh. Yes, this one here, sorry, base of Z. And one that is shared by X and Y, and X and Y shared means here. And you can see this is normally the real diagram, not this one. This one, when you watch, it looks like they are going all to one. That's not really the right diagram. So this one is the diagram. The problem here, I mean, not the problem, the point here is when you see this one means only they inherit from one B, but this one is actually how it looks like. This is that. All right, let's go on. So then they created a struct. They make their inheritance multiple from this one. We know, and you have to know this access specifier, what you can see. You can add it here too. And we talked already in our last videos, if there is no access specifier, what it means. You have checked this one struct. So they are all public access. And public means you have to check how they have go down. For example, it starts here with a struct. Then I make a public, and we learned the public access specifier means I take all what is public protected and stay public protected. The only thing which I can't access from here would be private, but we learned also struct is by default, if you don't specify an access specifier in the body, it's public. So you can see all comes together. You have all to know now what this is, but not difficult if you learned them. But yeah, we are learning them, so it's still difficult for beginners, but don't worry, we learn them. And then the last one is public. So here we can see already this will be go down to A as public. So which means I will have access to this one, right? So I can see that because of this one, and because you have to check this one too, because if this would be a private, that would be a dead end. Right? Why would be this a dead end? Because private means make all what public is private. And then if you inherit one more, you have no access here. So careful about this, but I think if you train this a little bit, you will get it. Understanding is not a problem. Training is very important here. But let's see what happens here. So here what we have here's a constructor. By the way, we will talk about constructors more in detail in the next video, because constructor is changing with inheritance too. But right now, let's watch this. We have here a constructor, and the constructor is doing what? It is assigning. And here we can see what they are doing. You can see modifies the virtual base subobject of member, subobject's member. So let's see, this X here is this one. Let's watch our diagram a little bit. Oops, sorry. So that I can explain you this a little bit with pictures. So what happens here is, let me go here a little bit and here. What happens here is, it says here, this xn here, x is my x here, n is that what I inherited from top. This is this first one here, this is the b, and b has this n in it. So x, you can see the x value has in it nothing, but I can manipulate the n because I have inherited b itself has nothing in it, just the inherited value. And it says here modifies the virtual b subobject's member, virtual b. And that's very important that you understand, when it's virtual, we have all who has the word virtual will share the same base. Okay, that means I have here 1. So I change it. Let's go here from this, right? I start here because I am in AA. Here I start. Here I modify it. I go to this X, because this is our resolution operator. We say check X. So go to X. Use xn, and xn means xn has inherited from here, because this arrow means I have inherited from b, right? I have what b is if it's, and again, if it's only accessible. So again, this p was public, and this one was inherited publicly. Public is accessible, right? Good. And then it says set it to 1. Very easy assignment. And then we go to the second one. We start again from AA. And it says now go to Y, because this class resolution operator says go to Y. I want that you go to Y here. And now set N, this what you inherit from B, to 2, right? And that is the same thing here. And you can see, but because they share here the same base, this not, set not, but they share. Right now, what I'm doing is I overwrite the first assignment of here, what I did here with the with this line. So careful about this, because if you share something and the last one who is doing an assignment on the same variable, you can see the last one is this one. We are using the both variables. The last one is overwriting the other one, and that can be sometimes cool if you know it, but sometimes really danger if you make it accidentally, because you expect it to, let's say, this line you would never assign when you have this line. In normal programming, you would never do something like that. Why not? Think about it. You know it is virtual, and then you assign a 2. You know this line of code was totally worthless. So careful about this later in inheritance, that you know what sharing means. They are overwriting the thing, the variable. So let's go on. What happens? So this one is overwriting this same variable to 2. And then let's go to the set, the last one, which is not virtual. You can see there is not the word virtual. Set here is creating its own base, which means I set now this n, which is in my base here, to 3. And now here is just an output. And here is, again, you can see what they did. The output is, put me out what xn is. So they say go and put me out what you have here in xn. Put me out what you have in yn. And put me out what you have in zn, right? And this is the part which you have to be careful. This is the line which becomes worthless because you have overwritten it with this one here. Because here you assign 1. They share the same base. I override this value with this one here, but important is I call still xn. You can see this is still distinct called, but the value is overwritten by the second one here. So, and if you understand this one, because better understand just this picture here, and then try to understand this one here with your own examples, try to create examples here. So I don't go now, I think over mine, that would take too much time now here. I could show you this one here as well. But because I already take so much time, you should create your own examples and try to understand this a little bit more in detail. We will go in the next video to constructors. This is the second part here, because the constructors are changing. We have to talk what the constructor is doing, how I can call it, and the kind of stuff like that. So if you have any questions so far, write it like all time in the comment sections. And with that said, see you in the next video. Have fun, and like all time, never give up. Bye.